Hi everyone, and welcome back. This video is going to explain and give you a visual for the following welding positions: flat, horizontal, vertical, and overhead. I'm also going to demonstrate a short weld in each of those positions for each joint. Here's an image that puts all the joints together according to the position that they're listed as. So again, flat, horizontal, vertical, and overhead. It's here that you can see that each position is given a number identifier. Flat is number 1, horizontal is 2, vertical is 3, and overhead is 4. We're going to stick to these 4 for this video. There are more, but that's for another time. You can think of the number designation system as sort of a difficulty scale, where typically flat welds are the easiest and overhead welding is the most difficult. So 1 being easy, 2, 3, and then 4 being the most difficult. We don't have these many various positions because one is more advantageous than the next. We just have them because you never know what you're going to encounter. Whenever you're putting assemblies together and you're welding things out in the field, you could come across a weldment that you have to weld in a different position, whether that's flat, horizontal, vertical, or overhead. You never know what your job is going to entail, so you need to be skilled in all these different positions. So let's begin with the butt joint and the flat position. If I give you sort of a blueprint example, this is what it's going to look like. You're going to see it from a top angle, a front angle, a side angle, and then you're going to be giving a 3D, well, sort of a 3D representation. Imagine sitting at your work table and you're just laying 2 pieces of material on the table flat, and then you're just butting them up against each other, tack welding them, and then welding it as it sits on your table. That's pretty much welding in the flat position. So think of your welding electrode pretty much being vertical, up and down in relation to the work surface. And here's a blueprint example of a lap joint in the flat position. You can see that it's still a lap joint, but it's tilted in a way so that your welding electrode can be straight up and down in relation to the work surface. And here we have a blueprint representation of a T-joint in the flat position. So it's still a T-joint, but you can see that it's been rotated so that way our welding electrode can access the weld root while being straight up and down. And here's a representation of a corner joint in the flat position. And here's the edge joint in a flat position. And that brings us to the horizontal position. So you can think of this as rotating the project piece so that way the area that is to be welded is looking right at you. That is, instead of looking down at the project to be welded, like you would in the flat position, we're just rotating it so that way the welding electrode extends out away from us, kind of like if you were to raise your arm right out in front of you and keep it parallel with the ground. The thing to remember when welding in the horizontal position is you want to make sure that your weldment goes from left to right or from right to left, depending on which hand is your dominant hand. And here we have a blueprint representation of a butt joint in the horizontal position. So you can see the electrode extends out away from us, but the weldment still goes horizontally, or left to right, right to left. And here you can see a horizontal T-joint. And this is also where horizontal gets a little tricky. So you can see that the electrode is slightly angled down. But as long as the electrode isn't straight up and down, this can still be considered a horizontal weldment. And moving on, here we have a lap joint in the horizontal position. And here's a corner joint in the horizontal position. And here we have an edge joint to finish off the horizontal positions. And that concludes the horizontal position, which of course leads us into the vertical position. So imagine you were just welding in the horizontal position. What you're basically going to do is you're going to rotate your project piece clockwise or counterclockwise so that your weldment goes up and down. Take this image of a vertical butt joint, for example. If you were to compare this to the horizontal example, it's almost the same, except that the project pieces have been rotated so that way in this position the weld goes up and down. Now, in a lot of cases, the weld should go from the bottom to the top, but there are two types of vertical welds: vertical up and vertical down. There are very special cases that will require vertical down, like sheet metal or other thin types of material, but in most cases, if it's not specified, always assume it's vertical up. And now we're moving on to the T-joint in a vertical position. And now here is a lap joint in a vertical position. Moving into a corner joint in the vertical position. And here's a vertical edge joint to conclude our vertical positions portion. You'll have to forgive me here. From my point of view, sticking the electrode underneath the workpiece actually looked like it was aligning it properly. But I can see here that it's actually a little crooked, and I'm sorry for that. Hang in there, everyone. We're in the final stretch. Now we're into our overhead positions. This is what a lot of employers look for when they're hiring welders. They want to be able to see if a welder can handle overhead welding positions, because to be honest, this is where the money's to be made. And so to start us off, we have the butt joint in the overhead position. In this case, you can kind of think of it as you're standing directly underneath of your welding project, and your welding electrode is pretty much going to be aiming up towards the ceiling. And now we're moving into an overhead T-joint. Up next is a lap joint in the overhead position. Now we're going to do an overhead corner joint. And last but certainly not least, here we have the overhead edge joint.